Section 6.2, addition, subtraction, and estimation with rational numbers. So just like we did with the whole numbers and the integers, we're just going to go through the four operations now with rational numbers. And so this section is all about addition and subtraction. All right, let's see if I can turn the page. There we go. Okay, so the first model we want to look at is an area model. So let's say we want to add 2/5 plus 1/5. Well, both of those have the same denominator, right? So I can use a pi to illustrate fractions with a denominator of fifth, where I've broken the pi into 5 equal-sized pieces. So this first circle has 2 shaded pieces out of 5, so it represents 2/5. And this has 1 shaded piece out of 5. And if I combine them into one circle, I see that I have 3/5. Okay, so that's called the area model. Now that's not the only way we could do that, and so I'll show you another way in a little bit. We can also use the number line. So if I want to add 2/5 plus 1/5, I'm going to draw my number line and mark off fifths and do addition just like we did with whole numbers or integers. So 2/5 and 1/5 are both positive, so I'm moving to the right. I'm going to first start at 0 and go right 2/5. And then from there, I'm going to go right another 1/5, which takes me to 3/5. So overall, I get 2/5 plus 1/5 lands here at 3/5. Okay, in general, we have rules for adding rational numbers with the same denominator. So as long as their denominators are the same, a over b plus c over b, I can just add the numerators. So a plus c all over b. If I don't have like denominators, I need to use the bottom box. And that essentially is what we do when we get a common denominator. So notice if I were to rewrite this with a common denominator, I'm going to do it off here to the left. Well, the easiest common denominator here is to choose BD, right? And so I would need to multiply the first fraction by D on top and bottom, and the second fraction by B on top and bottom. And now you're back up to the top rule, right? All right, so how would we use area models to illustrate addition if our denominators aren't the same? So let's look at the top first. So this is my pi model. So first I'm going to draw a pi cut into 3 pieces and shade 2 of them to illustrate 2/3. And then the second one is a pi cut into 4 pieces with 1 shaded to illustrate 1/4. Now what's happening over here on the right? Well, I want to cut my pies into equal-sized pieces. Here, that means that I need to cut each of these pieces on the left into 4 pieces. For a total of 12 pieces there. And in the second fraction, I want this also to be broken into 12 pieces. So that means each of my 4 pieces need to be broken into 3 pieces. Okay, now when I look at these, when I go to shade the total circle with both the blue and the yellow shading, I'm going to shade 1, 2, 3, 4, 5, 6, 7, 8 blue pieces and 1, 2, 3 yellow pieces. And that gives me a total of, so 8 and 3 here, a total of 11 twelfths now. You can also illustrate the area model using bars. So here I've taken, I know it's a little hard to read because I've got the orange on top already, but I've got, let me see if I do black. I've got 1 solid bar, and I want to illustrate 2/3, so I'm going to break my bar into 3 equal-sized pieces and shade 2 of them. That's the blue shading there. And on the bottom, I want 1/4. So this bar needs to be the same size. My holes are still the same, except this is now cut into 4 equal-sized pieces, and I've shaded one of those. Now the orange shading is what I do to make each of those bars broken up into the same number of equal-sized pieces. In this case, 12, because that's my common denominator. And you can see here that when I do that, on top I have 1, 2, 3, 4, 5, 6, 7, 8 12ths. So that's where the 8 12ths comes from. And then 1, 2, 3 12ths on the bottom. And so 8 12ths plus 3 12ths is 11 12ths. Both of these count as area models. This is using pies up top. And down here we're using bars. Okay. All right, I'm going to pause here and let you try a problem, and then we'll come back.